All right, so we are first going to integrate using our integral rules. So remember, with antiderivatives, integrals, you add stuff. So you add 1 to the exponent, divide by the new exponent. So this will become x squared is going to be x to the third over 3 minus 3x to the first. So we add 1 to the exponent to get 2 over 2. Now, what is different about this question is that we have our bounds. So that means that we have a definite integral. And when we have a definite integral, we are going to write our little bar and say it's from -1 to 2. And then we will plug in the upper bound first minus the lower bound plugged in. So if I plug in my upper bound, I'm going to have 2 to the third over 3 minus 3 times 2 squared over 2 minus, and then the lower, we need to be super careful that all of the lower is subtracted off. So I'm going to plug in -1, and I always kind of put a big bracket here for the lower to emphasize that this negative needs to get distributed. So I will have -1 to the third over 3 minus 3 times -1 squared over 2. All right, now you need to be able to do this without a fancy schmancy calculator. So you have 2 to the third, which is 8 over 3, minus 4 times 3, so that gives you 12 over 2, so that gives you 6, minus, and what I do is I evaluate the bracket and then deal with the other part of it. So I have negative to the third power, so that gives us a -1 over 3, minus 3, this -1 squared gives us a positive over 2. And again, what I usually do is just focus on what is this quantity inside of the bracket. So I would need to get a common denominator. And if you do that, it's fine. But your common denominator would be 3 over 3 here and 2 over 2 here. The other thing I want to point out, though, just really quickly, is you see how like you have an 8/3 here, minus a 1/3. So that's going to become 9/3, which then is going to completely eliminate the fraction. So if you notice that, you might want to just distribute and then go from there. So you could get a common denominator and figure out what this is and subtract it off, or, and we're going to go through this, distribute and combine like terms. And that usually is going to be the easier thing to do. So I'm not going to get a common denominator. I'm just going to say, okay, let me distribute this and see if anything combines. Because here's the thing, this x cubed over 3, this x cubed over 3, when I plug in, it might combine with something. So that's kind of the hope there. All right, so we have a double negative, so we have positive 1/3, and again, double negative here, positive 3 over 2. And again, I just really want to emphasize there's nothing wrong with getting a common denominator, figuring out what that is, and then subtracting it off. All right, so if I combine here, I have 9 over 3. So these two guys together become just 3, minus 6, and then plus the 3/2. So this becomes -3 plus the 3/2. And then I do have to get a common denominator, of course, for this. So I'll multiply the -3 by 2 over 2. So that gives us -6 plus 3 over 2, leaving us with -3/2. So you go through all this work, and remember what this is telling us is that this definite integral here is equal to -3/2.